Here I have QGIS Desktop open with 4 DEMs covering the study area. And raster data are often provided in tiles like you see here. For example, each raster may have the spatial extent of a USGS 7.5 minute quadrangle. That's the case here. In such cases, it's often necessary to merge the data sets together to form a seamless raster covering the study area. So with these 4 DEMs, each has cell values that represent the elevation above sea level. And if I open up the layer properties for one of these, each one is stretched on a black to white color ramp from the minimum to the maximum values. And since each raster has a different minimum and maximum value, each image has its own custom stretch. And so you see the hard boundaries between the 4 data sets. But what we want is a seamless raster that covers the study area. To merge them into one DEM, I'll use a Saga processing tool called Merge Raster Layers. So to do this, I'm going to go to the Processing menu and open up Toolbox. I'll expand the Saga tools, and I'll expand Grid Tools, and I'll find the Merge Raster Layers tool. So I need to tell the tool which rasters I'm going to merge. So I'm going to click the ellipsis button. The 4 loaded rasters show up, and I'm going to select all of them and click OK. I'm going to change the preferred data storage type to 4-byte signed integer, the interpolation method to bilinear interpolation, and I can change the setting to overlapping cells to first value in the order of grid list. This is just telling it how to deal with the case where there's one cell value overlapping another. And I'll save out the resulting file. Call this merge.tiff. So I'll create a geotiff. And before I run this tool, one note on interpolation. When you're creating a new raster, the data is going to be interpolated from these inputs, and there's different ways of doing that. Generally speaking, nearest neighbor is used for discrete rasters, so something that has discrete boundaries represented in it. The other methods are more suitable to continuous rasters, like this elevation data set. And the bilinear interpolation is one of the favored techniques for working with elevation data sets. I'll click Run to run the tool. I can remove the original raster layers. And now I'm left with my seamless DEM mosaic across the study area. As I mentioned before, though, my study area encompasses just a portion of this merged layer. So I'll want to clip this merged raster to my study area boundary. To accomplish this, I'm going to use the QGIS raster clipper. So I'm going to go to the raster menu, to extraction, and open up the clipper. The input raster is the one I have left in my project, merged grid. And I'll click select to choose my output dataset, which I'll call study area DEM.tiff. Next, I need to change the clipping mode. By default, it's set to extent, which allows you to enter 2 coordinates, the upper left and the lower right corners of your rectangular box that you want to clip it to. Instead of using that method, I'm going to use a mask layer. And my mask layer is my study area vector polygon layer. And I'll click OK to run the tool. Processing is complete. Click Close. Turn off the original mosaic. And now I have a clipped DEM that is fit exactly to my study area. This workflow is commonly needed to prepare raster data for analysis. Now I have a seamless DEM that covers my study area, so it's going to reduce the size of the data on disk, which will reduce processing times. It also leaves my original raw DEMs untouched, and I can go back to those if need be. In the next task, we'll take a look at something called raster pyramids.